Welcome back to another week of geometry, week 5. This week we're going to continue with module 14, trigonometry for triangles, all triangles, and look at law of cosines. Before we do that, just a couple announcements. Review, remember everything is posted on Schoology. Okay, if you go to the geometry page, scroll on down. Okay, remember there's our semester grading guidelines are there. Office hours. The link is there for when you can come on in. Remember to stop on in. If you have any questions, stop and see. Chat with your teachers. Stop in and say hi. Some of you haven't seen for a very long time. It'd be nice to see your face. So stop in, join us. Unit 5, Schoology. Independent practice and quizzes is where all the assignments have been so far. And the week 5 ones will be there as well. They're down at the bottom. And then we've got the week 5 table with everything you need to do for week 5. You've got the link. There's the link to the week 5 Google Doc, which you also will be emailed through Schoology. So you can open that up, read through the message. Okay. One of the big things I'm going to make mention of, some of the tips for success. Make sure your calculator is in degrees and not radians. Have been seeing some people get some wrong. So if you go to your calculator, remember doing that by going to mode, degrees, where my mouse is, needs to be highlighted. Mine already is in degrees, but scroll down to it. If it's not, you have to hit enter. Once you go click on it and scroll below, make sure degrees is highlighted. Okay, that's how you make sure that your calculator is in degrees, because if you're not in degrees, everything will be wrong. And you've got all the links here for the 2 tasks for this week. Can be found in the Google Doc. So if you are having problems with Schoology and you can't access it, they're all there. I think we've gotten past a lot of those issues, and not even seen too many issues with Schoology in the last week or 2 here. So they're all there, and they're there for you. You got the blank notes. There will be a link to the video right here. Obviously it's not there yet because I'm in the process of making the video. You got the complete notes. Click on the link. There's a flow chart. We'll talk about that in a minute. And then your independent practice. And remember, you have to submit that on Schoology. Submit your answers in Schoology and we're done with that. And we've got task 2 down below. So if we start out, if you're able to, print the blank notes. Here's the link. Click on it. There you've got the blank notes. You can print out and follow along as we go through the video, or you can complete them on your own and check with the completed notes and then come back to the video for any that you maybe don't get. And if you can't print them out, again, it's not a necessity that you print them out. You can just follow along by writing down on pencil and a regular piece of paper, blank paper or notebook paper, whatever you might have. Obviously, if you're watching this, you found the link to the video. Right here's the link to the video. Remember in the video, there are shortcuts down at the bottom. Okay, if I bring up, just to show you, here's a video from last week. Okay, if you click on show more, all of these time frames here, all these time frames will take you to the different spots in the video. Okay, yeah, so you can skip around, or if you need to come back to see something, you can. Okay, you know, pay attention to, especially entering it into the calculator, how you should enter information in. We've got our completed notes, so you can check those out. Flowchart. So right now we've been focusing on every lesson, every task has been focusing on doing one particular thing. We will be having a quiz next week in week 6, where you'll have to put all of these together and you won't be told which one you have to use. So we're going to talk a little bit more about this flowchart today in the lesson, but that's where you can get this. If you can print it out, I would recommend it print it out. It tells you what to do. It also has all the formulas that you need right there for you in one spot. And then your assignment is over here, your independent practice, problems that you will need to do for today's lesson. So that'll bring us back to, now let's get started on our lesson. Again, trigonometry for all triangles. Looking at module 14, today we're going to focus on law of cosines. Task number 1, today's task is going to focus on finding a missing side measure using the law of cosines. In task number 2, we'll talk about finding the angle measure using law of cosines. Again, independent practice. If you have any questions on the law of sines worksheets or anything from last week, or as you're doing through this, remember, stop in during Google office hours. Okay, they're on Schoology there. Click, find out when the times are. Click on the direct link to it. If the times don't work for you, email your teacher, talk with them, set up a time with them where you can meet with them one-on-one at a different time. Okay, we're all available here to help you out. Just let us know. You got to reach on out, send us an email. We're checking it every single day. Law of cosines. So here's our flow chart. A couple questions we need to ask ourselves. Is it a right triangle? If the answer is yes to that, you have two options that we have explored. We've explored using SOHCAHTOA, which we did the first couple weeks, and the Pythagorean theorem. Notice the Pythagorean theorem, you have to know two sides. You use that to find the third. SOHCAHTOA, you either know two sides and you're finding an angle, or you know one side and an angle and you're trying to find a second side. Well, if it's not a right triangle, SOHCAHTOA or Pythagorean theorem does not work. The question we have to ask ourselves then, because we have two options, is there an opposite angle side pair? In week 4, we did explore that. So if our answer is yes, that we have an opposite pair, that we know the measure of both the side and the angle for, we're going to use law of sines, which is what we did in week 4. We used that to find both a missing side or missing angle. Well, what we're going to look at today does not have an opposite pair. Then so if our answer is no, we're going to use the law of cosines. That is our next step. That's what we're going to look at. That's our next option. So as we go and look at the warm-up here, I want to find the measure of AB. That's what I want to find the measure of. Side C. Well, it's not a right triangle, so I cannot use SOHCAHTOA. Do I have an opposite pair? I've got side B, but not angle B. I've got side A, but not angle A. I have angle C, but not side C. There is no opposite pair that I know both the measures of. And because I only know one angle, I can't find either of the other two. Law of cosines will not work. Or law of sines will not work. Well, what can we do? One option, draw in the altitude for the triangle and divide triangle ABC into two right triangles. If I do that, now that I have some right triangles, I can use SOHCAHTOA and do some work here. So if I look at the triangle on the left, triangle ACD here, I'm going to try to find the height. I want to find H. If my reference angle is 70, I want to find H. That side is opposite of 70. I do know the measure of AC, which is 12, which is the hypotenuse in triangle ACD. Which trig function uses opposite and hypotenuse? Yeah, sine does. So I can write a ratio, write an equation. Sine of the reference angle, sine of 70, equals h over 12. Solve for h. Multiply both sides by 12 to clear fractions. Cancel out. I got 12 times sine of 70 equals h. Type that into my calculator. 12 times sine 70, 11.2763 is my answer. I now know what h is. The problem with the triangle on the right is I don't know a reference angle. I only know one side. Well, my next course of action is I'm still going to look at triangle ACD. And what I want to do is find the measure of CD. Okay? I want to call that X. I want to find that measure. Well, my reference angle is still 70 degrees. I still know the measure of 12. 12 is still the hypotenuse. But which side is X? X is the leg that is adjacent. So which trig function uses adjacent and hypotenuse? Yeah, cosine does. So I'm going to use cosine. I'm going to write my equation. Cosine of 70, cosine of the reference angle, equals x over 12, adjacent over hypotenuse. Well, let's go ahead and solve. Multiply both sides by 12 to clear fractions. I get 12 times cosine of 70. Let's type that into my calculator. 12 times cosine 70 equals 4.1042. Because I'm using rounded decimals, and I'm going to be using those later on, I am rounding to 4 decimal places. Okay. The more decimals you use, the more accurate it will be at the end. So I've got 4.4102. But how does that help me? Remember, I want to find AB. I need to know another measure. But notice, BC is what? 16. If we go back to way back at the beginning of the year, we talked about the segment addition postulate, which said the measure of CD plus the measure of DB would equal the measure of BC, or CB. Well, I now know CD is 4.1042. I know that BC was 16. Can I solve for DB? Subtract 4.1042 from both sides. I get 11.8958. I now found the measure of DB. How is that going to help me? Because now look at the triangle on the right, triangle ADC. I know 2 out of the 3 sides in that right triangle, which means we can go back to and use what? The Pythagorean theorem. A squared plus B squared equals C squared. A being the height, which is 11.2763. B being the leg we found at the bottom, which is 11.8958. Square both of those sides. You get 127.1549 plus 141.5101. Add that together. 268.6650. How do I solve for C? Take the square root of both sides. Take the square root of 268. Take the square root of C squared, and I get C C equals 16.39. A lot of steps there, isn't that? Is there a shorter way? That's the question. Can we do this quicker and shorter with less work? Well, that's what we're going to explore. And yes, there is. Law of cosines is an option. So I'm going to talk you through just a little proof here for law of cosines. Okay? Got a right triangle here. Triangle ABC. Well, if I divide this triangle into two right triangles, I can use the Pythagorean theorem such that h squared plus x squared equals b squared from the triangle on the left. Now the bottom, okay, we call side A. Well, if this blue segment is x, we can find the green segment as a minus x, the length of a minus x. So I'm going to use h squared plus a minus x, quantity squared, equals c squared. If I solve both of those triangles for h, I get h squared equals b squared minus x squared, and h squared equals c squared minus the quantity of a minus x squared. Well, since I solved them both for h, I can set them equal to each other. Now, I did flip-flop them around here, okay? So I have c squared minus the quantity a minus x quantity squared equals b squared minus x squared. I want to solve this for c. So I'm going to add the a minus x quantity squared to both sides. Now I'm going to work on simplifying this. Well, a minus x quantity squared means a minus x times a minus x. So a little bit of algebra. I can now distribute. I can multiply those together. If I do that, it becomes a squared minus ax plus x squared. I'm going to combine some like terms. I combine the two minus ax's to make it minus 2ax. I can also combine the like terms in that. I can combine negative x squared plus x squared, and they cancel out. So I'm left to c squared equals b squared plus a squared minus 2ax. Using the cumulative property, I just flip-flop the a squared into b squared, so c squared equals a squared plus b squared minus 2ax. Well, from the picture up above, cosine of angle C is going to equal x over b. If I look up here, cosine of angle C equals x over b. And we use that in our warm-up. If I solve that for x, I multiply both sides by b, I get x equals b times cosine of c. So in my last equation here, I'm going to get rid of x with b times cosine of c. So I have c squared equals a squared plus b squared minus 2ab times cosine of c. Notice I have a formula here that only involves sides A, B, C, which are the three sides of the triangle, and one angle, in this case, angle C. That's the law of cosines. Here's our formulas for it. Now, there are three different formulas depending on which angle you know, or which side you want to find. So when do we use law of cosines? When we do not have an opposite pair. We're going to use that today. We're going to use it to find the missing side of any triangle. In order to do that, I must know the measure of two sides, and I have to know the measure of the angle that's between those two sides. As I said on my equations today, when I'm determining which one of these three I should use, okay, I always want to put the side that is by itself as being the side that I would like to find the measure of. So if I want to find the measure of side A, I would use the top one. If I want to find the measure of side B, I would use the middle one. If I'd like to find the measure of the bottom, or side C, I would then use the third or the bottom formula that we see here. So let's look back at our warm-up. We did that, 4 steps, a lot of work. Can I do that easier? I want to find the measure of side C. If I label my triangle, there's the side I want to find. I want to find AB. Let's call that side C. Well, let's label the other. 16 is across from A, so let's call that A. 12 is across from B, so we'll call that side B. Well, which formula do I want to use? If I look back, I want to use the third one, the bottom one. C squared equals A squared plus B squared minus 2AB times cosine of C. I'm just going to plug in the measures. I don't know side C, so I'm going to leave that blank. A is 16. So I'm going to replace A with 16, make it 16 squared. B is the measure side B, that's 12. So I'm going to replace B with 12, 12 squared. Minus 2 times A, which is 16, times B, which is 12, times cosine of angle C, and angle C was 70 degrees. Now the nice thing about law of cosines, when I'm finding a side, I don't need to do a whole lot with this. I can type this into my calculator all at once. So if I go to my calculator, I can type that in by doing 16 squared plus 12 squared minus 2 times 16 times 12 times cosine 70. There I go. 268.6642. C squared. But that's not side C, is it? How do I solve for C? Just like in the warm-up when I did the Pythagorean theorem, what did I do? I have to take the square root. If I take the square root of C squared, I get C. Well, I need to take the square root of 268.6642. Now I'm going to show you a little trick in your calculator. I don't want to type in the square root of and round this number. I remember we said we don't want to round to the end. So I'm going to do square root, which is second the x squared bottom, square root. Instead of typing this entire number in, if I hit second, it's the negative key. You can see where my mouse is. Above it, it says ANS in blue. That's going to take the answer. It's going to take the previous answer, which means it's going to type in the entire thing for me. And end up with 16.3909821. 16.390. Round that to 2 decimal places, my final answer. I get 16.39. Notice that's the exact same answer we got when we did the warm-up. Is this shorter? Is this simpler? Yes. Is there less steps that I have to remember? No. I take one formula, plug in the numbers. Now all I gotta do is type in my calculator and take the square root. Law of cosines is not real difficult for us to find and use. So example number 2, let's take a look at another one here. I want to use the law of cosines to find the measure of side C. So which law of cosines formula am I going to use? C squared equals A squared plus B squared minus 2AB times cosine of C. The side I want to find is the side that has to be by itself. So if they were asking me to find side A, I'd use the one that had A squared by itself. Side B, I'd move to the one with B squared by itself. So I'm using the one with C squared again. Okay, let's label the sides. 10 is across from A. B is across from 12. And I will be honest, it doesn't really matter how you label A and B. They could be flip-flopped. Doesn't matter. A is 10, so I don't know C, so C squared equals A is getting replaced with 10. B is getting replaced with 12. Minus 2 times A, which again is 10, times B, which is again 12, times cosine. It's a capital C, it's angle C, which is 40 degrees. So I have C squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 40. Let's type that into our calculator. 10 squared plus 12 squared minus 2 times 10 times 12 times cosine 40. Remember, we need to make sure our calculator's in degrees. I checked mine at the beginning of the lesson. Make sure we're changing the modes in degrees, because if you're not getting these same answers, that could be one option why you're not doing it right. Equals 60.1493. How do I solve for C? Square root. Now I don't want to round to the end, so I'm going to do square root. I'm going to use the second answer, which is the negative key, ANS. It's going to take the entire number for me, and end up with 7.755. Round that to the nearest hundredth, 2 decimal places is 7.76. Now, just a quick note here, I do want to show you, if I do take the square root of 60.14, I typed in 6.14. 60.14, get 7.754, which I'd be off by 1 decimal place here. So not too far off, but there is that opportunity to be off. So let's get in the habit of using the answer feature. Okay. Example number 3. Use the law of cosines to find the measure of side B. So which formula do I need to use? B squared equals A squared plus C squared minus 2AC times cosine of B. Because I'm solving for side B, I want the formula that's got the B by itself on one side. So B squared. Let's identify, label A and B so I know which numbers to put in. Let's call 8A because it's across from angle A. We'll cross 11C because it's across from side C. Plug our numbers in. A is 8, C is 11. Again, A is 8, C is 11. Capital B is angle B, which is 100. So B squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of 100. Type that into our calculator. 8 squared plus 11 squared minus 2 times 8 times 11 times cosine 100 equals 215.5620. How do I solve for B? Square root. Square root, I'm using the answer feature again, so it's the second negative key, which is ANS. 14.682. Round that to 2 decimal places, I get 14.68 as my answer. Again, if you have any questions and you're still not getting it, stop in office hours, Google Hangouts, join your teacher, ask. We'll touch base and help explain things a little bit more for you. Example number 4. We've got an application problem here. A surveyor with a transit at point A. Right here they are. Point A here. That's where the surveyor is. Sites points B and C on either side of a Salem pond with the distances indicated. So the distance from A to point B is 15 meters. The distance from A to point C is 21 meters. She finds that the measure of the angle between the sighting of the two points is 72. So angle A here is 72 degrees. We want to use the law of cosines to find the measure of BC. We're trying to find how far it is across the pond. Now we can't just measure it. Don't have our boat, so we can't go across it, but we can use that. So I want to find what? Side A. I know so if I go back to my flow chart again, not a right triangle. I do not have an opposite pair, so I'm using law of cosines. I want to use the one with A squared by itself, because that's the side I want to find the measure of. Well, let's label our sides. Since it's got a B and C, let's call 21B. We'll call 15C. A squared equals B is 21, C is 15, minus 2 times B is 21, times C, which is 15, times cosine of capital A, which means angle A. Angle A has a measure of 72 degrees. Do note, remember, the lowercase letters indicate sides. The uppercase letters indicate angles. I can type that into my calculator. 21 squared plus 15 squared minus 2 times 21 times 15 times cosine of the angle, which is 72 degrees. I get 471.3192. How do I solve for A? Take the square root. Using the answer feature, so second square root of second negative, which is the ANS answer. It's taking the entire number there. You get 21.709, which rounded to two decimal places is 21.71 meters. That's the law of cosines to find an angle side. Is that a lot easier than doing the warm-up? I think we did all 4 examples in the time it took to do the warm-up. So law of cosines is definitely easier than trying to divide the triangle. It is not very difficult. You just got to make sure you're typing it into your calculator. So summary, I want to wrap this up. So if I consider triangle ABC here to the right, what information would I need to know to find the length of AC? So if I want to find AC, I would need to know the measure of what? 2 of the sides, right? Well, AC is B, so which sides do I need to know? Well, the sides not B, which are A and C. So I'm trying to find side B, so I would need to know sides A and C, and I would also need an angle. Well, I need the angle that's across from side B. The angle that's between the 2 sides I know the measure of, which would be angle B. Which equation would I use? Well, I'm trying to find side B. So I want the equation that is B squared by itself. B squared equals A squared plus C squared minus 2AC times cosine of B. Now, in summary, remember, I go back to this. If I look at these 3 formulas, what is really the only difference? They're all the same formula. I'm just interchanging A's, B's, and C's. That's all I'm doing. And what I will tell you is this, is if you get to homework and you have a triangle that doesn't have A, B's, and C's on it, relabel your triangle. It might be RST. Well, let's rename our triangle RST ABC. And then I can label it with the corresponding sides with little a, little b, and little c if you want to. So your independent practice today is week 5, task number 1, the law of cosine sides worksheet. For each problem, you should have a drawing with labels. All of them here are giving you drawings, so you don't need to worry about that. Write an equation. We're using law of cosines for all of them, but still write your equation. Show your algebra. Now, obviously, we're typing on your calculator, but write down on your paper what you're typing in your calculator. Write your answer with the units inappropriate and round all answers to the nearest 100, 2 decimal places. And then submit it on Schoology. So if you're looking for your homework, independent practice 14.2, law of cosine sides worksheet, clicking on that. That'll bring up your blank copy of the worksheet. Again, as I pointed out, like notice number 2 and 3 are triangles PQR. I'll label them ABC. Instead of PQR, call this A is P, B is Q, R is C, and go from there. When you're done, there's one thing I want to show you about the independent practice. when you submit it on Schoology, similar to like we did with Law of Cosines. Remember, make sure you're in degrees. We're asking to show your work. So the first formula is going to ask you to set up the Law of Cosines. So if I look at question number 1 in the homework, c squared equals, well, a is 13 squared plus 9 squared, that's side B, minus 2 times a, which is 13, times blank 4, which is 9, times cosine of what's the angle? 96. So when you write your equation, and then you should be entering in the numbers. You don't have to type in the squared, that's already did it, because the blank in the parentheses indicate the first number being squared. The second blank in parentheses indicate the second number being squared. And we've got 2 times 2 numbers, well, you're typing those in, times cosine of the angle. And then at the end, once you type that in your calculator, take the square root, that's our answer. You'll type that in from there. And you'll notice each problem in the homework has one like that. So like it's q squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of 80. Again, that's a little helpful hint on your homework for that. And the last thing is we have our little challenge here for you, for some of you. If you're not up to it, you don't have to do the extension. It's a challenge problem. So like I said, if this is being easy and you want to be challenged, here's your opportunity. So your triangular hiking trail is being planned. At an average walking speed of 2 meters per second, how many minutes will it take a hiker to make a complete circuit around the trail? Well, first you got to know the distance, right? Which means I need to know how long side B is, don't I? Because I need to find the entire thing. So eventually, I want to find the perimeter. Okay? Well, before I can find the perimeter, I want to find side B. Well, not a right triangle, can't use SOHCAHTOA. Do not have an opposite pair, so I cannot use law of sines. I'm going to need to do law of cosines. I'm using the one with b squared by itself because I want to solve for side B. B squared equals A is 200, C is 410, so 200 squared plus 410 squared minus 2 times 200 times 410 times cosine of 100. Type that into my calculator. You end up with b squared equals 236,578.3011. How do I solve for b? Take the square root. And b is 486.39 meters. So now that I know all the sides, I can find the perimeter. Add up all the sides. 200 plus 410 plus 486.39, and I get 1,096.39 meters. That's the distance of this trail. But the question is, how long will it take for them to hike around it? Well, they're walking at a speed of what? 2 meters per second. So if I need to find the time in seconds, well, let's take our distance and divide by 2, because they're going 2 meters per second. So every second they cover 2 meters. So if I take 1,096.39 divided by 2, I get 548.195 seconds. That's how long it takes. Again, the question was, how many minutes? Well, how do I find the minutes? Let's take 548.195 and divide that by what? 60. End up with 9.14 minutes. That's our extension. That's week 5, test 1. I hope you enjoyed it. Have a good week. Stop in, say hi. Have fun, enjoy. We all miss you and like to see you. We can do that during office hours, but we'll get through this together.